Okay, we're going to do problems chapter 9, 17 to 22. I'll do most of the assignment with you. First one here, sorry, let me just get my screen a little bit bigger. First one is 17a. You can either distribute that 3 in, which I'll do here, or you could just divide by 3 from the beginning. It's 6k minus 3 is less than 9. Add 3 to both sides, 6k is less than 12. Divide by 2 on both sides. Oh, sorry, I wrote equals. It's k less than 2. Notice that the inequality did not change direction there because we divided by a positive 6 on both sides. This next one, I think some of you will have difficulty with just because the fractions are here. The first thing you would do, if it's 2p divided by 5, the first thing you should do is multiply by 5. So we get 2p is less than or equal to 30. And then divide by 2. P is less than or equal to 15. And that's that. So the point there is, instead of doing the 2/5 all at once, if you're not very comfortable with it, since it's divided by 5, we'll multiply by 5 at the beginning, and since it's multiplied by 2, we'll divide by 2 here at the end. Okay, the next one is negative 2 plus 8n less than 2. If we add 2 to both sides, we get 8n is less than 4, and divide by 8 on both sides, n is less than 4/8, also known as n is less than 1/2. Notice the sign again did not change. Okay, this next problem, the first thing I'll do is add 4 to both sides, 7t greater than or equal to 2t, because when you add 4 to both sides, the 4's both go away in tandem. Now you can subtract 2t from both sides, and notice this will not change our sign. 5t is greater than or equal to 0. So divide by 5 on both sides, t is greater than or equal to 0. Those of you who subtracted 7t here, you would end up with your t on the other side, but you would have to switch your sign in the end because you'd end up dividing by a negative number. So just be careful of that. Your t should be greater than 0. Or for those of you who like the alligator should be eating a t. Okay, number 19 is a bit of a review question. If you remember this was a type 2 or type 3, one of those two. You're trying to find the equation of the line using the slope and a point through which this line passes. If you remember what we do know about a line, everything can be summarized in this equation, y equals mx plus b. We'll put our slope in here. I'm going to take this y value, which is 2, and put it in, and the x value is negative 6 plus b. Now you might stumble with this fraction, but it's not a big deal. We just put it over 1. That'll become 18 over 5. So 2 equals 18/5 plus b. That's a 2. It looks kind of like an a. Still looks kind of like an a. And now subtract 18/5 from both sides. So minus 18/5. These ones, of course, are gone. Minus 18/5. So we need to do 2 over 1 minus 18 over 5. So get the denominators to be the same. This will become 10 over 5. So 10 minus 18, that's negative 8 over 5 equals b. So there's our b value. Our slope value is given up here. So remember, the only two things you would ever need to know to write an equation of a line are slope and y-intercept. We've got the slope negative 3/5 x minus our y-intercept 8/5. All right. Okay, number 20. They ask you to multiply these two things out, and when you do, you'll see that it's 3x squared plus x minus 10. Then they ask you these two questions. Before we do that, though, I just want to do a small thing off to the side here. Just looking at red for a second. 8 times 9 is 72. We all know that. So if I asked you what 72 divided by 9 is, you'd say, oh, that's 8. 72 divided by 8, that's 9. Okay, if you go back up here, we have something times something is 3x squared plus x minus 10. So if you do 3x squared plus x minus 10 divided by x plus 2, you should get the other part, 3x minus 5. And similarly, if you take this divided by 3x minus 5, you should get the other building block that you started with, x plus 2. Alright, onward to 21. It's a quadratic equation. You're asked to solve it. It does not tell you to use factoring or the quadratic formula. So the first thing I would do is make sure everything is on one side. So I subtract 12.5 from both sides. We get this, 3x squared plus 2.5x minus 12.5 equals 0. And now you could try to factor that. If you're excellent at factoring, that might work fine for you. If not, quadratic formula. A is 3, B is 2.5, and C is negative 12.5. And now you just fill out your quadratic formula. You know the formula. Okay, the last one here, 22. I skipped A and B. A, you could use our old method. B, if you tested that one, should be not factorable because you can't get anything that multiplies to be negative 2 and adds to be 11. C here, the reason I want to do this is because it's one of these pull out and front deals. If you set up the box, it would not work out for you. You wouldn't have proper numbers here to split up. Your diamond won't work out. So you should go back here. The first thing you should always think is, what can I pull out? 3x times x minus 4. And that's it. There's nothing left to do after that. So I wanted to look at C because a weakness of ours has been taking out common factors. Now, from the part D, you could try one of our traditional box method, or you could go in, and this is what I advise always, is to look at it and say, what can I take out first? 2x squared minus 7x minus 4. And now look inside and try a box method on that. I'll do it over here. I have to kind of scrunch it in. We get our 2x squared and our negative 4. That multiplies to be negative 8. So now we think multiply to be negative 8, add to be negative 7. Those numbers are negative 8 and positive 1. And now when you factor, you get 2. Oh, I'm sorry, I left out my x's. You get 2x outside with an x, 1, and negative 4. So you're left now with 2x plus 1 and x minus 4. All right, that's it.